and I'll show you my DC motor collection today. You can see the alternators here. These are all the alternators, brushless motors and some DC motors, the first and on the second. See, I have a lot of them. And again here and below that. Hi guys, these what you see are some of the BLDC motors that I have, and these are few of my permanent magnet DC motors. And guys, we know that if we connect the two DC motors back to back and turn the shaft of one DC motor, the shaft of the other DC motor also starts rotating if it's a permanent magnet DC motor. But are we going to see the same thing if we connect two BLDC motors back to back? Let's find out. When I'm turning the shaft of the wind turbine three-phase generator, the shaft of the BLDC motor is rotating, but it is also vibrating. But that does not mean that it is not going to work. When taking the situation vice versa, you can see that it is getting not even a single spun in one singular direction. It's vibrating even more in this case. So guys, let's interchange the wires and then try. But as you can see that it is still vibrating. Let's try rope rotation. Still no change. When taking the situation vice versa, this motor is showing much more steady spin when compared to the other one. Still, it was very tight. Now guys, I also have an e-bike motor and its RPM is almost equivalent to the wind turbine alternator. And there is a great possibility that if we connect the wires of the two machines together, then things might work out. Let's try it. So guys, as you can see that we are pretty close and it's working pretty good, although there's still a little vibration and the shaft gets really tight, but not as much as it got in the previous case. Let's give this motor a spin this time. Nope, not at all good. It was working better in the previous way when I operated the wind turbine alternator and used the e-bike motor as motor. Now guys, I'm going to go with the only option I'm left with, which is connecting the e-bike motor with the e-rickshaw motor and then try. And guys, this way it is working much more better. And also I have not connected the right combination. Here you can see I have connected blue to yellow and yellow to blue. Let's try and connect it properly and then see if it works even better. And guys, I feel like it is working much better now. When I turn the e-bike motor, it is running smoothly, and so is the e-rickshaw motor that is connected to the three-phase wires of the e-bike motor. So the color of the wires connected seems like that also matters. I'm not sure, but it is somehow working better that way. Plus also, there is no surety which motor is going to work back to back with which one. But as far as I think, if we get two identical motors, then it's going to work much more better. I'm still using two different motors. So guys, I have connected this three-phase brushless wind turbine alternator mechanically with the belt and pulley system to a high RPM 4000 RPM permanent magnet DC motor. And with that DC motor, I am going to run this wind turbine alternator, which is then going to generate electricity. And guys, this is the washing machine BLDC motor that operates on 230 volts AC. I salvaged it from that. So what I'm going to do is I'm going to connect the three wires of the washing machine BLDC motor to this wind turbine alternator, and then hope that it is going to run the washing machine BLDC motor. So guys, let's connect the wires of the high-speed permanent magnet DC motor to the DC motor speed controller and then test that everything is working fine. So guys, now I'm going to turn on the switch. Okay, you can see that it is working super smooth without any problem. Well, I have few bulbs here. I'm going to try and test it as an electric generator also. Let's go with this 12 volts car headlamp bulb. Wow, you can see such a low RPM and still it is generating pretty good amount of current. Yeah, the wires are getting hot. Okay, so guys, the wires of the washing machine BLDC motor are being connected to the wind turbine alternator. After that, I'm going to turn on the switch to see if it works or not. And this time, after changing the direction of the wires, you can see they fit perfectly to the wind turbine alternator. So starting the setup, Okay, go. You can see that it is not running, but it is only vibrating. So guys, this time after turning it on, I'm going to give it an initial push and hope that it starts running. But yes, sometimes things start working vice versa wise. So let's turn this motor and hope that this starts running. Okay. Whoa, now that was something really good. Okay, so what I'm going to do is I'm going to run it this time. You see, this is running. Then start it slowly. Ho 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 ho. Yeah, now I'm getting it. Okay, and yeah, it is running finally. All I have to do is get it synced. Okay, slowly and slowly. Yeah, it has synced. Okay, once again. You see, as soon as it gets synced, it is running smoothly. But as soon as the sync is lost, it stops running. You can see guys that this motor is running and torque is also good. Yeah, pretty good torque. Oh, the belts broke. Now guys, I have finally found the way of running the two BLDC motors back to back. You can see when I'm turning the washing machine motor, the shaft of the wind turbine alternator brushless motor is running pretty smooth. Now this is the back view of the washing machine motor. Somehow I have connected a crank and it is running really smooth, and like the torque needed to run it with this is also not that much. You can see how fast it is running, pretty good. Now this method is not applicable when I use all types of DC motors, which you have already learned if you have watched this video completely. But if you can find the correct partner for your BLDC motor, then it is going to work back to back with the initial one. 3.70 amps, DC amps. Haha, cool, right? Hey guys, in this video I'm going to teach you different methods with which you can self-excite universal motors at home. The project was requested by the previous video contest winner Julian. So guys, you will find 4 wires coming out of the universal motor, 1, 2, 3 and 4. 2 of which must be connected to each other, and the remaining 2 must be open for connection to run this motor. And guys, you're also going to need this 12 volts to 220 volts inverter or DC to AC converter. So guys, first comes the connection of the bridge rectifier. Okay, so what you have to do, you have to connect the AC terminals to any one of the 2 terminals that are left out, meaning not connected. Now the other AC terminal will remain open, and to the DC output terminals this inverter or DC converter will be connected. Okay, mind the positive and negative. Now with that being done, I will use this high capacitance capacitor bank. You can see a single capacitor is rated at 110,000 microfarad at 15 volts DC. Now guys, connect the negative, which is this black one, negative, to this black of the universal motor. Now to the positive, you have to connect the left out wire of the rectifier. Now comes this 5 volts 2 amperes mobile charger. You see, 5 volts 2 amperes. So I have to connect it to the inverter. Okay, connected. Now there are 2 left out pins, black and red, to which I'm going to connect this extension. Okay, with red being positive and black being negative, and connecting it accordingly to the capacitor bank. Black to black, negative, red to red, positive. Now all I have to do is start the setup by giving power supply to this motor, and that is going to run this universal motor. And let's see what happens. DC motor speed controller. Okay, that's the AC side. This is the DC side to which I'm going to connect the terminals of the treadmill motor. Always turn off the supply first. Make sure at the start the speed is at 0. This is the bulb that will be connected to the terminals to which this inverter has been connected. Yeah, this one I will connect afterwards. Okay, let's go. Well, there was some problem in the wiring. Oh, you see, the motor is turned on. Although at present it is showing low battery, but in few moments it should gain like charge, and the low battery light should go away if it is working. It seems like it is working. The light is going. I'm going to give you a closer view. Yeah, you see the low battery light is going away, and the main light is getting brighter and brighter. Somehow the light just turned off. When I'm touching the terminal, then the light of the inverter is glowing brighter. I don't know why is that. You see, it is glowing brighter. Let's connect it permanently to this point. It seems excited, but it is like getting dim and dim and dim and turning off. I think the bulb has got fused. Guys, now what I have done is, to one terminal coming out from the universal motor, I have connected the rectifier's terminal, and the other also I have connected the rectifier's terminal. Okay, and the output of the rectifier DC is going to feed the inverter, and this 5 volts charger is connected here, that is going to feed this excitation capacitor, which is going to excite the universal motor. So this is another way that I'm going to try. Whoa, it is getting auto excited. Huh? What the hell? I think I am seeing something here. Oh, the wire is hot. I didn't even like charge the capacitor bank, and everything is like smelling over here. I think I should limit the feedback voltage from the capacitor to the universal motor. I think this one should do. Let's try this. Bulb is not glowing, meaning that there is no charge in the capacitor bank. Let's see if it can get self-excited like it did before. Whoa! Yeah! Oh, yes! I seriously did it, guys. Yeah! This is a self-excited universal motor, guys. Self-excited, no battery given, automatically excited. Now this is going to be the third or fourth of my unbelievable inventions. I knew that if I'm going to set a resistive feedback, it is going to work. No excitation not needed. Oh yes. Oh yeah. That inverter is feeding it. You see that it is glowing better and better, and in some time that low battery voltage indication is going to go out, or some of the wire might just get burnt, because at present it is heavily loaded. And this thing is not present on YouTube anywhere on the internet. That's the first, and I'm the one to do it. Oh yeah. Cool. Yeah. Let's measure the voltage. That is only 1 volts charged. Let's measure the voltage across the bulb. Oh, the wire is super hot, guys. This is connected to that. Okay, so I can get the voltage from here. One terminal over here and one over there. Yeah, at present I'm getting somewhere around 5.27 volts. If I go a little bit faster on the treadmill motor, obviously the bulb is going to glow a little more. Would you like me to do that? Say yes. Okay. Yeah, it is working. Let's turn off the lights and then check it out. Let's see how bright it is. Let's turn it off. You see it's turned off and it is still glowing because of the circulating magnetic field. I seriously just love electricity and there is so much to learn still. Now guys, you all must be thinking that this method is super complicated. Well, the good news is that there is another shortcut, super shortcut, at which you are not going to need any of these. Okay, so for that I'm going to use this 12 volts UPS battery. Next, what you have to do is run this motor with a DC source, not an AC but a DC source. Okay, you can see that it has started running. Initially, when it was running on AC, the residual magnetism was 0 because of changing magnetic poles. The pole which was initially north became south and then again north. So there was 0 residual magnetism. But now that I've fed a DC source to it, the poles have a residual magnetism. Now using that residual magnetism, I am going to self-excite it without any external source. This is a bulb, you see, incandescent bulb. Okay, let's connect its terminals. Now let's turn the supply on and see if it gets self-excited. Okay. You see that it is self-excited now. Cool, right? If you have a DC source, you can attain that residual magnetism like which is present in car alternators. And when you have done that, then you can get it self-excited, but not if it is continuously running on AC source. No other wire given, okay? Super bright bulb. Cool. Let's measure the generated current. Okay. .70 amps. DC amps. Haha. Cool, right?